Welcome. In this video, we are going to build a real professional website and put it live on the internet on our very own custom domain, secured with that little padlock you see on safe websites. And we do the whole thing end to end, from a single empty folder on a laptop all the way to a live site that anyone in the world can open. We use Amazon Web Services, AWS, the same cloud the biggest companies in the world run on. You do not need any prior cloud experience. I will explain every step, every screen, and every command in order as we go. Nothing is skipped. First, let me show you exactly what we are building, so you know where we are heading. This is our finished website, live right now at vnlabs.com. Look closely at the address bar at the top. You can see a padlock, and you can see HTTPS. That padlock means the connection is encrypted and secure. And vnlabs.com is a real domain name that we own. This page is not running on my laptop anymore. It is served from Amazon's network, and it loads fast anywhere in the world. By the end of this video, you will have built this exact thing yourself. So let me show you the full plan. Here is our roadmap, and we follow it in this exact order. Step 1, we build the website's files on our own computer. Step 2, we learn how web addresses actually work using a small trick on our own machine. Step 3, we save our code to GitHub. Step 4, we put our files into the cloud using Amazon S3. Step 5, we register a real domain name with Route 53. Step 6, we add a free security certificate for HTTPS using a service called ACM. Step 7, we put a global delivery network called CloudFront in front of our site for speed and security. And Step 8, we make the whole thing deploy itself, automatically, every time we change the code. 8 clear steps. Let's start at Step 1. Step 1, a website, at its core, is just files. So on my laptop, I have made a folder for our project, and inside it are 2 files. The first is index.html. HTML is a language that describes the structure of the page, the headings, the text, the buttons. The second is style.css, which controls how it looks, the colors, the fonts, and the spacing. That is genuinely all a basic website is. Now, to view it, I run a tiny web server on my own computer and open it at localhost, port 8000. Localhost simply means this computer right here. The page loads. But notice the address. It is just localhost and a number. That is not a real name yet, so here is one of the most important ideas on the whole internet. A domain name is nothing more than a friendly label that points to a number, an IP address, which is the real location of a computer. And your own computer has a tiny private phone book in a file called etc. hosts. Watch. I add one line, this IP address equals the name vnlabs.local, I save it, and now that name opens our site. I just invented a domain. But only my computer knows it. To let the whole world use a real name, we need to put that same kind of entry into the internet's global phone book. Same idea, bigger phone book. Hold on to that picture. Step 3. Before we go to the cloud, we need a safe, professional home for our code. That is Git and GitHub. Git is version control. It takes snapshots of your files over time, so you can always go back, and so a team can work together without overwriting each other. Watch the commands. First, git init, which turns our plain folder into a tracked repository. Then, git add to stage our 2 files. Then, git commit, which saves our first snapshot, with a message describing it. Now the history is saved, but only on my laptop. So with a single command, create, I create a brand new repository up on GitHub and push, that is, upload all our code to it in one step. Our website's code now lives safely online with a full history. And in a few minutes, this exact GitHub repository is going to become the source that automatically deploys our live site, local, to GitHub. Done. Step 4. Now, the cloud. What is the cloud really? The cloud is just other people's computers that you rent by the minute instead of buying and running your own. Amazon Web Services is the biggest provider, and for storing a website's files, the perfect service is called S3. S3 stands for Simple Storage Service. Think of it as an infinite, extremely reliable hard drive in the sky. In S3, you create something called a bucket, which is just a named folder in the cloud. Watch the commands. First, I list our bucket, and you can see our 2 files, index.html and style.css, are already inside it. Next, this is important, I run AWS S3 website, which tells S3 to stop being just storage and start serving our files like a real web server, using index.html as the homepage. But by default, buckets are private. So next, I turn off the block public access setting, and then I apply a bucket policy, a small rule that allows anyone on the internet to read and only read our files. And just like that, our site is live on a real S3 web address. The command checks it and gets back HTTP 200, which means success. But look at that address. It is long, it is ugly, it is not our name, and it is plain HTTP with no padlock. Over the next steps, we fix all three of those problems. Now, here is something important to understand. Everything we just did in the terminal with typed commands, we can also do by clicking in the AWS Web Console. They are simply two different doors into the exact same AWS. The Web Console is the visual, point and click website, the one we are looking at now. It is friendlier when you are learning, and it is the best way to see what already exists and to explore. The command line, the terminal, is the opposite. It is faster, exact, and repeatable. You can save your commands in a file and run them 100 times perfectly, which is why professionals and automation always use the command line. So which is better? Neither in general. The honest answer is, you use the console to learn, to look around, and to check your work. And you use the command line to go fast and to automate. In this video, you're seeing both, side by side, for every step, so you understand exactly what is happening underneath. So let me now show you, in the visual console, the very same things we just built in the terminal. This is the S3 console, and this is our bucket, named vianlabs.com. Under the Objects tab, here are our two files, index.html and style.css, the exact files from our laptop, now sitting on Amazon servers. You can see their size and the date we uploaded them. This upload button is how you would add files by hand, though very soon we will make this happen automatically. Notice the tabs along the top, Objects, Properties, and Permissions. We are about to use the next two. Under the Properties tab, if we scroll to the very bottom, we find the setting that turns a plain storage bucket into a website. It is called Static Website Hosting, and you can see for our bucket it says Enabled, with the hosting type set to bucket hosting. This is the visual version of that AWS S3 website command we just ran in the terminal. This single setting is what tells S3, when someone visits, hand them back the index.html page, like a proper web server would. Without this, the bucket is just silent storage. And under the Permissions tab is the rule that lets the public actually see our pages. This is the bucket policy, and it is written in JSON. Let me read it with you, because it is simpler than it looks. The statement says, effect, allow. The principal is a star, which means everyone, anyone on the internet. The action is S3, get object, which means download a file, and only download, not change or delete. And the resource is our bucket, with a /star, meaning every file inside it. So in plain English, this policy says, allow anyone to read any file in this bucket. That is exactly what a public website needs, and nothing more. Step 5. And this is the part everyone is waiting for, actually buying your own domain name. In Route 53, we click Register Domains, and we get this search box. I type the name I want, vianlabs.com, and I search. Now look closely. It says vianlabs.com is not available, and that is simply because we already own it. We bought it earlier in this project. But this is the exact screen where you buy a domain. Underneath, Amazon suggests available alternatives. And this is the important part. It shows you the price per year for each one. A normal .com is usually around $14 or $15 a year. Here you can see a .org for $15, a .net for $17, and a fancier .io for $71. To buy one, you simply click Select next to the name you want. It drops into this cart on the right. You click Proceed to Checkout, fill in your contact details one time, and confirm the payment. That is the entire purchase. The domain is then yours for a full year, and with auto-renew turned on, it stays yours. We already did exactly this for vianlabs.com, so let's go and look at the domain we own. Step 5. Time for a real name. A domain like vianlabs.com is something you rent, usually for about $15 a year, from a company called a registrar. AWS has its own registrar built into a service called Route 53. This screen is our list of registered domains, and here is vianlabs.com that we registered. You can see the expiration date, almost a year away, and auto-renew is set to on, so we never accidentally lose our name. Transfer lock is also on, which protects the domain from being stolen or moved without our permission. When you register, you also turn on privacy protection, so your personal contact details are hidden from the public. This domain is now genuinely ours. The moment you register a domain in Route 53, Amazon automatically creates something called a hosted zone for it. Think of the hosted zone as our own private section of the internet's giant global phone book, the section where we get to decide what our name points to. Here are its details. You can see the hosted zone name, vianlabs.com, a unique hosted zone ID, and the type, a public hosted zone, meaning the whole internet can look it up. Down here are the name servers, the 4 Amazon addresses that officially answer for our domain. And notice the record count. Our zone currently holds 6 records. Let's look at what those records actually are. Here are the 6 records inside our hosted zone, and each one is a single line in our section of the phone book. Look at the very first one. It is our domain, vianlabs.com, its type is A, and crucially, in the alias column, it says yes. An A record normally points a name to an IP address, but an alias record is special. It points our domain directly at another AWS resource, in our case, the CloudFront network we will see in a moment. There is a matching record for www.vianlabs.com, also an alias. The NS and SOA records are the standard records Amazon manages for us. And these 2 records starting with an underscore are special validation records that prove to Amazon that we really own this domain, so it can give us our security certificate. This is the real version of that etc. hosts trick from the start, a name pointing to a location, except now the entire world can read it. Step 6. Now we earn that padlock. When you see HTTPS and a padlock, it means the connection between the visitor and the website is encrypted, scrambled, so nobody in between can read it or tamper with it. To do that, a site needs an SSL or TLS certificate. Normally, these cost money and are a hassle to renew, but AWS gives them away for free and renews them automatically through a service called ACM, the Certificate Manager. This is our certificate. Look at the status. It says issued with a green tick. The type is Amazon issued. And down here, under domains, it covers both vianlabs.com and www.vianlabs.com, and both show success. To get this, ACM asked us to add those special validation records we just saw on Route 53. Once it confirmed we owned the domain, it issued the certificate in a couple of minutes. We now hold the key to the padlock. Step 7. We have files in S3, a name in Route 53, and a certificate in ACM. Now we tie them all together with CloudFront. CloudFront is a CDN, a content delivery network. Here is why it matters. Our files sit in one place, but our visitors are all over the world, and without help, someone far away waits a long time for the page. CloudFront fixes this by keeping copies of our site in hundreds of locations around the globe, so every visitor is served from the one nearest to them almost instantly. This is our distribution. You can see its own CloudFront address up here. And look down at the settings, at the alternate domain names. There they are, vianlabs.com and www.vianlabs.com. This distribution takes our S3 bucket as its source. It attaches the ACM certificate for the padlock, and it is set to always redirect visitors from plain HTTP to secure HTTPS. This is the piece that makes our site fast and secure for everyone, everywhere. Let's confirm the whole stack from the command line, and then add the final professional touch. First, I ask ACM for our certificate, and it reports our domain and the status, issued. Then I check our CloudFront distribution, and it reports deployed and its address. Then I list the records in Route 53, and there is our domain, pointing at CloudFront. And now the real test. I run curl against https://vianlabs.com, and it returns HTTP 200 success over a secure connection, and our page title, vianlabs, comes straight back. It is genuinely live. Now, the final touch, and it feels like magic. Right now, if I change the site, I would have to re-upload it by hand. Real teams never do that. They use CI/CD, continuous deployment, with GitHub Actions. The moment you push your code, a robot logs into AWS securely, using a modern keyless method called OIDC, so there are no secret passwords to steal, copies your new files to S3, and refreshes CloudFront. Here you can see that automated run and its result. From now on, shipping an update is just git push. The robot does the rest. And there it is, the finished result. We open https://vnlabs.com, and our page that started as an empty folder on a laptop is now live on the real internet, on our own domain, loading instantly from the nearest corner of the world with a green padlock proving it is secure. Take a second to appreciate the full path. Files on our laptop, pushed to GitHub, stored in S3, wrapped in a certificate from ACM, delivered worldwide by CloudFront, and found through our domain and Route 53. That is how real websites are built. Let's lock it all in order. 1. A website is just files, HTML and CSS, on a computer. 2. A domain name is a label that points to a location, and DNS is the global phone book, the same idea as our etc. host trick. 3. Amazon S3 stores the files and can serve them as a website. 4. Route 53 gives us a real domain and connects it to everything. 5. ACM gives us a free certificate for the HTTPS padlock. 6. CloudFront delivers the site fast and secure worldwide. And 7. CI/CD, with secure OIDC, makes every future update automatic with a single git push. And here is why this matters beyond one web page. What you just learned, storage, DNS, certificates, content delivery, and automated deployment, is the real foundation of cloud engineering, and companies pay very well for exactly these skills. You can now host any site, any project on your own domain. I'm Vian. Now go build yours, and I will see you in the next one.